Section 1.6 talks about more on linear systems and invertible matrices. So a system of linear equations has 0, 1, or infinitely many solutions. So either 0 solution, 1 solution, or infinitely many solutions. We already established that. There are no other possibilities, we know that. Now, if I take a system of equations and write it as a matrix equation, then I could use the inverse and multiply the left side by the inverse. Well, let me write that on the side. So if I have ax equal b, I could multiply by the inverse of a on the left hand side of each side of the equation. Oops. Well, this will give me the identity matrix, and the identity times any vector or matrix it is the vector, and this will give me C, and that will give me the solution to the original variable that I'm looking for. Now, if I was trying to solve a system of equations where ax equal b1, the same ax equals some others, third and fourth, I could write that as an augmented matrix. I could go ahead and figure out the inverse of each. That's a lot of work. Or I could simply say, you know what, let me put an A, then put B1, B2 all the way and make them all augmented but into one matrix. And when I solve this system of equations, I would have solved every single one of these cases. We'll do an example and I'll talk more about this and how it applies. Now, theorem 1.6.3 says, let A be a square matrix. That means the number of rows equal the number of columns. If B is a square matrix, satisfying BA equal I, then B and A are inverses. If B is a square matrix satisfying AB equal I, then B is also the inverse of A. The only way you can get an I by multiplying two matrices if they are inverses of each other. Now, one more to go. Let A and B be square matrices. Again, number of rows equal number of columns. If AB is invertible, then A is invertible and B must be also invertible. So in this section, we're going to focus on inverse, invertible, and using that to find a solution. Here's a system of equations. It says solve the system by inverting the coefficient matrix and using theorem 1.6.2. On your exam, I'm not going to say theorem 1.6.2 because then you wouldn't know what that means. I would say solve the system by inverting the coefficient matrix and using matrix equation or inverse equation. I'll talk more about that in class. For now, let's write this out. This really writes as 4, -3, 2, -5 multiplied by x1, x2, and that is a -3, 9. Now, how do you find the inverse? We have two ways. If it's a 2 by 2, we have a shortcut. Let's use that. If this is A, this is X, and this is B. So what I'm going to do, I'm going to find the inverse of A. I'm going to say, well, let's see. A inverse, I have two ways of doing that. Either I do my magic and make the left side the identity, and whatever is here will be the inverse. Or since I am aware of how to do a 2 by 2, and I know there's a shortcut for it, I could actually do it. Let's do that. The inverse of A will be 1 over the determinant. That's -20 plus 6. You swap the diagonals and you multiply the non-diagonals by a negative. So this is 1 over -14. So the inverse is 5 over 14, -3 over 14, 2 over 14, or simply negative 2 over 14, or 1 over 7, and 2 over 7 negative. So that doesn't look very pretty, but that's normally how inverses are. They're not always really nice, and but so what am I going to do? I'm going to multiply the left side of this by 5, 14, -3 over 14, 1 over 7 and negative 2 over 7, and I'm going to do the same here. Now the left side, you really don't have to actually work it out. If you have time on the test, it'll be wise to do that to check if you did it right or wrong. This is going to give me the identity matrix. Now let's see if that works. I'll get 20 over 14, I'll get 20 over 14 minus 6 over 14, that's 14 over 14, which is 1. I'll get negative 15 over 14 plus 15 over 14, that's a 0. I'll get 4 over 7 minus 4 over 7, that's 0. And I'll get negative 3 over 7 plus negative 3 over 7 plus 10 over 7, that's 7 over 7. There you go. Again, you don't have to check that. On a test, all what you have to do is tell me this is the identity for a 2 by 2, and the identity times any vector or matrix is the matrix or the vector. But here, I'm going to multiply those out. I'm going to get 2 by 2. I'm sorry, 2 by 1. This is 2 by 2, and this is 2 by 1. So I'm going to get, and let me make a bit more space. I'm going to get negative 15 over 4 minus 27 over, not 4, 14. And here I'm going to get negative 3 over 7 minus 18 over 7. So negative 21 over 7 is negative 3, and negative 20, 30, 42 divided by 14. Oh, that's also a negative 3. Wow. So the solution turns out to be, for this problem, x1 and x2 are negative 3. Or simply negative 3, negative 3. There. That's really what we're going to focus on for a while. There are other ways of solving these systems, but that's how we're going to do it. Here we're going to do the same. We're going to say, look, there's A. So the whole work is going to be on finding the inverse. That's 5, 3, 0, 3, 3, 1, 2, 2, 1, multiplied by x1, x2, x3. And that's going to yield, I'm going to leave space for a 3 by 3, which is the inverse once I find it. 4, 2, 5. And pretty much I'm going to find the inverse, multiply the left side by it, and that's going to work out just like we did in the previous problem. Let's see how that works. This is going to be a bit of work, however. This is 5, 3, 0, 3, 3, 1, 2, 2, 1. And if I want to find the identity, there's only one way of doing that. So first things first, I'm going to multiply row 1 by 3, row 2 by 5, make one of them negative, put the result in row 2. So the first goal is to make that a 0, that's already a 0. There's 1. So for row 1 I'm using, but I'm not changing. If I multiply row 1 by 3, that's 15, 9, 6, 3, 0, and 0. Multiplying this by negative 5, negative 15 plus 15 is 0. Negative 15 plus 9 is negative 6. Negative 6 plus 6 is 0. 0 plus 1 is 1. Negative 6, negative 5 plus 1 is negative 5. And let me just make sure that's correct. Multiply by negative 5, negative 15, negative 15, negative 6, negative 5, negative 10. Oh, I messed up right there. When I multiply this by negative 5, that's negative 10. Negative 10 plus 6 is negative 4. There. Now the next step is to take those two and make that a 0. So the way I'm going to do that, I'm going to take 6 row 3 plus row 2 in row 3. That will take care of business. 5, 3, 2, 1, 0, 0, 0, negative 6, negative 4, 1, negative 5, 0, and 0. If I multiply this by 6 plus 0, that's 6 minus 4 is a 2. That's a 1. That's a -5. And 6 plus 0. Okay, there we go. And now this is what we're going to do. We're going to make those two 0. I'm going to take twice row 3 plus row 2 in row 2. And I'm going to take negative row 3 plus row 1 in row 1. So what I'll get, if I multiply this by 2, 0 plus 0 is 0, minus 6, 4, 2 plus 1 is 3, 2, negative 10 minus 15, and 12 plus 0 is 12. If I take negative this row and add it to the first, 5, 3, negative 2 plus 2 is 0, negative 1 plus 1 is 0, 5 plus 0 is 5, and negative 6, almost done. Now the next step is to make that a 0. So if I take twice row 1, add it to row 2, put the result in row 1, because I want to make that a 0. So what would happen? Again, the process is tedious. Now here, we'll see. So I have 0, 0, 2, 1, negative 5, 6, 0, negative 6, 0, 3, negative 15, 12. And if I multiply row 2 by 2 plus, that's a 5, oh wait, time out. If I multiply row 1 by 2, that's 10, plus 0, that's 10. 6 plus 0 is 0, 0 plus 0 is 0, row 2 by 0, that's a 3, by 2, that's 10, that's negative 5, and negative 12 plus 12 is a 0. Now if I divide row 1 by 10, I'll get 3 over 10, negative 1/2, and 0. Row 2 by negative 6, I'll get 0, I'll get negative 1/2, negative positive 15 over 6, that's 5 divided by 3, 5 over 2, and 12 divided by negative 6 is negative 2, and the last one, if I divide by 2, I'll get 1 over 2, negative 5 over 2, and a 6, so 3 over 10, negative 1 over 2, and 0, I'll get negative 1/2, 5 over 2, and negative 2, 1/2. Now, whether this is right or wrong, that's irrelevant. It's the process, really. I mean, it's very important to get them right, but it's the process I'm going after in this case. So if I am to go ahead and say, well, look, this is going to give me the identity for a 3 by 3, and that's going to simply give me x1, x2, x3. Now here I'm going to try and figure out what this equals, and that's going to be 3 by 1. I'll get, when I multiply this, I get 12 over 10. 12 over 10 is 3 over 6, 6 over 5. 3 times 4, 12, 6 over 5. 6 over 5 minus 1 plus 0. So again, this might be wrong. That will be 1 over 5. For the second, I'll get negative 2 plus 5 minus 10. 12, that's negative 7. And for the third, I'll get 2 minus 5 plus 30. 32 minus 5, so that's 27. So the solution is 1/5. Again, this might be a mistake. We're after the process more than anything. You know, making an error is deemed to happen since there's so much calculation involved. Now, when I get to this problem, they say, okay, solve the system of equations given the values of b's. Notice we have two values. So the way I do this, I say, well, there's 3, there's 5, there's 1, there's 2. First, I will list those 0, 1. I'll put a line, and then I'll put those negative 3, 4. Now, if I solve this like I do traditionally, and traditionally meaning let's make that a 0. So take negative 3 row 2 plus row 1 in row 2. But do that to the entire row. Well, guess what? Then you're solving really those two. You could have 3, you could have 4, it doesn't matter. If I multiply row 1 by row 2 by negative 3 plus negative 3 negative 6, negative 3, and negative 12. And if I add it to row 1 but put the result in row 2, that will be 0, negative 1, negative 3, and negative 15. Now, if I take 5 row 2 plus row 1 in row 1, so 0 plus 3, that's 3, negative 5, that's 0, negative 15 plus 0 is negative 15, and negative 65, negative 68. Take row 1 divided by 3, put it back in row 1. Take row 2, multiply it by negative 1, put it back in row 2. I'm looking at 1, 0, negative 5, and 68, 15. It does divide it. No, 6, 14. That doesn't divide evenly. Let me check. Yeah, I messed up on that one. Because if you take negative 5 times 15, that's 65, that's 75. That's negative 78. So when you divide 78 by 3, that does divide. And let's see. 3 divides 7 2 times. You have 18 left, and 3 divides that 6 times. Okay, and here if I take root divided, so switch all the signs. Here I'll get, in this case, the solution is negative 5, 3. And in the second case, the solution is negative 26 and 15. And there, I could do multiple systems at once. That's another way of using matrices. Next problem up. Determine conditions on B's, if any, in order to guarantee a linear. So, well, we start again with this, the traditional. We're going to always start the problems by the traditional method, which is augmented matrix. So 6, negative 4, B1, 3, negative 2, B2. So I want to make that a 0 at first stage. If I take negative twice row 2 plus row 1 and row 2, that will do the trick. So 6, negative 4, B1. If I multiply this by negative 2, that's negative 6, F4, and negative 2, B2. And if I add those, that's a 0, that's a 0, that's B1 minus 2B2. Let me make that bigger. So here, we notice that for this to have a solution, B1 minus 2B2 must be 0, or B1 must be 2B2. That's the only way you can get a solution in this case. Now the next problem up. This is going to be a tough one. Solve the matrix equation for x. Again, we're going to do this. We're going to go ahead and figure out the inverse of this matrix and multiply both sides by it. And let's see how does that play. This is going to be a bit of work. So we're going to say here, x is going to equal the inverse multiplied by 3, 2, 1, 6, 7, 8, 9, 1, 3, 7, and 9. That's really how it's going to work. It's really, that's the idea. It's really like this. Again, we're going to write this, that's 8x equal c. So we're going to take the inverse of a. This is going to give us the identity, so we're going to be left with x. And this is going to give us some matrix B, and we'll figure out the solutions from there. So let's see how this works. Again, this x is not a vector, actually it's a matrix. My mistake. Okay, so what do we have to do? We have to find the inverse. Again, that's a lot of work. So let's start with that. There's the idea. If I start with -2, 0, 1, 0, -1, -1, 1, 1, -4, 1, 0, 0, 0, 1, 0, 0, 0, 1. First order of business, I'm going to take twice. Now I could switch row 1 with row, I could switch row 1 since they want that always. Yeah, you don't have to, but I could say take row 1 and switch it with row 3. So that makes life simpler. 1, 1, -4, 0, 0, 1. Those I'm going to leave alone. And this is going to be -2, 0, 1. Again, you don't have to really do that. I'm going to take twice row 1 plus row 3 in row 3. If I multiply row 1 by 2 plus 2, that's a 0. 2 plus 0 is a 2. -8. -8 plus 1 is a -7. 0 plus 1 is 1. 0 and a 2. And let me just make sure. It looks right. Okay. And then what I'll do, I'm going to make that a 0. I'm going to take twice row 2 plus row 3 in row 3. Again, I wish there was a shortcut. There isn't. Of course, I could divide row 2 by a negative if I want. Multiply this by 2, that's 0. By 2, that's -9. By 2, that's 0 plus 1 is 1. 2 plus, that's a 2. And 0 plus 2 is a 2. Alright. And now I'm going to go ahead and make that a 0 and that a 0. And we're going to do that by taking, let's see. Now I'm going to take row 1 here. Since now I don't need it anymore. I don't need to be negative, that is. I'm going to take row 2 and put it back in row 2. So that's going to make these positive, and that's a negative. Much better. Now I'm going to say, well, let's make those 0. Watch how I'm going to do this. I'm going to take lower that a bit. I'm going to take 9 row 2 plus row 3 in row 2. So if I take 9 row 2, that will be 0, 9, 9, 0, negative 9, 0, add it to row 3, 0, 0, negative 9, 1, 2, 2. If I add those, put that in row 2, 0, 9, 0, 1, negative 7, 2. That part is done. And if I take 4 row 2 plus row 1 in row 1. So for row 2, that is 0, 4, 4, 0, negative 4, 0. Add it to row 1. And this one remains. Almost there. All what I have to do now is make that a 0 and I'm done. I'm going to take negative 9 row 1 or 9 row 1 minus 5 row 2. It doesn't matter. Put in row 2. Put in row 1. So multiply row 1 by 9. That will be 9 plus 0, that's 9. That will be 9 minus, that's a 0. Now, if I multiply row 1 by, that's a 0 plus 0, that's a 0. 0 minus 5 is negative 5. And here I'll get negative 36 plus 45. 3 times 5 is 35. Oh, that's a negative 1. And if I multiply row 1 by, if I take row 1 by 9, that's a 9. And this is by negative 5, negative 10. 9 minus 10 is negative 1. And we all know how the inverse works. Let me show you really quick. The inverse would, oh, what did I miss? You can get the inverse by dividing row 1 by 9, row 2 by 9, and row 3 by a negative 9. So multiplying on the left hand side, I'm going to get x to equal the inverse multiplied by 4, 3, 2, 1, 6, 7, 8, 9, 1, 3, 7, and 9. And let's see if that's doable. Well, the inverse, divide row 1 by 9. That will be negative 5 over 9, negative 1 over 9, negative 1 over 9. Second by 9, 1 over 9, negative 7 over 9, and 2 over 9. And the third one by negative 9, negative 1 over 9, negative 2 over 9, negative 2 over 9. And there it is. Okay. And if I multiply those, what do I get? This is 3 by 3. This is 3 by 4. I'll get a 3 by 4, which is the solution to this matrix. And of course, just to point out a few of how these work, if I multiply this, let's see. I'll get the first entry. Negative 20 over 9 plus 6 over 9, negative 20 over 9 plus negative 14 over 9 minus 1 over 9. So let's see, negative 20, oh no, I'm sorry. They're all negative. Okay, it's going to be this multiplied by this. That will be this first entry. So that is negative 20 minus 6, that's negative 26, minus 27 over 9 is negative 3. To get the second, I use the second, and that's this entry. That's 4. 4 minus 42 is 40. 4 minus 42 is 38. 38 plus 2, that turns out to be 4 minus 42 is 38. 38 plus 2 is 40 over 9. Am I doing this right? Why is not making sense? Okay, that is making sense actually. So 4 minus 4 minus 42 is negative 38. Negative 38 plus 2 is negative 36. That's a negative 4. And the last one you get, again, this here times this here. That's negative 4 minus 12, negative 16, negative 18, negative 2. And the list goes on. And if you do this, this turns out to be negative 25 over 9, negative 40 over 9, and negative 23 over 9, negative 25 over 9, negative 40 over 9, and negative 32 over 9. As for the last entry, that will be negative 23 over 9, negative 44 over 9, and negative 37 over 9. And that's pretty much how we do it. Again, a long process, but that's what it is.